All right, thank you for joining us today. And in this video, we are going to practice. Still, we are using the Leibniz theory, right? Let's jump right in. So I saw this nice question. I was like, okay, let's go through together and see how we can show that if we have this function, then using the Leibniz theorem, this is equal to what? 0. So this is what we are going to do. Let's pick the question. So the question is y to the power m plus y to the power minus 1 over m is equal to 2x. So this is what we have. Now this is what we are going to do. We are going to form a quadratic function and we use the quadratic formula to, generate something. So the first thing that I'm going to do is, because this is minus, I'm going to multiply through by y to the power 1 over m, right? So that I can form the quadratic function. So I'll multiply the first term by y to the power m. I'll multiply the second term also by y to the power 1 over m, and then 2x, the last term here, by y to the power 1 over m, right? So using indices, the base are the same, so I can add the top. So when I add 1 over m to 1 over m, I'm going to have y to the power 2 over m plus, now this is negative, this is positive, so when I add it, I'm going to get it to be 0, and I'm going to have 2x y1 over what? M. So that's what I'm going to have. Now I can write this one as 1 over m to the power 2. So when I multiply this one back, I will get what is here. Now here we are assuming that y is not 0. So if it is not 0, then y to the power 0 will give us 1, which will be equal to 2x y1 over m, right? So let's form the quadratic function. So, or the equation, this will be minus 2x y1 over m. Let me put this one into parentheses, plus 1 is equal to 0. So I move this one right here, becoming negative. So we can see that we form the quadratic function where this is like x, this is like x, right? And we know that quadratic function is of the form ax squared plus bx plus c is equal to 0, right? So when you do that, now our x is the one in the bracket here. So here it means that a is equal to what? 1. Then our b will be equal to negative 2x, and then our c is equal to 1, right? And we know the quadratic formula. The quadratic formula is of the form, if we are using y, so let me use the same y that we are using here, y to the power 1 over m, then the quadratic formula is of the form minus b plus or minus root of b squared minus 4ac, all divided by 2a, right? So what we are going to do is we are going to do substitution and then we work with that. So y to the power 1 over m will be equal to, what is b? B is minus 2x plus or minus root of, what is b? Still minus 2x minus squared minus 4. A is 1, c is also 1, all divided by 2 times 1, right? So what are we going to get? When we simplify, this and this is going to give us something like 2x, right? Plus or minus, then we are going to have something like, here will be 4x squared, then this one is going to give us minus 4, all divided by 2. So this is what we are going to have, right? So let me write this one in the next page, then we'll see how we are going to write this one. Let me capture this one very well. Okay, I can even copy it here. So this one is okay, good. So let's check what we're doing here. So here we said y to the power 1 over m is equal to, then let me paste what we, good, we have something like this. So now let's go through the process and see what we can do here. This one can be written as 2x plus or minus. Now I can factor 4 out from the one under the root, then I have this form. Then this is 2x plus or minus. Now this one can be written as root 4 times root of x squared minus 1, or divided by 2. We are going to have 2x plus or minus root 4 is 2, then root of x squared minus 1, all divided by 2. This one can be written as 2x divided by 2 plus or minus 2 root of x squared minus 1 divided by 2. So we can see that this will cancel this one too will cancel this. So we are going to have x plus or minus root of x squared minus 1. So this is what we are going to get. But what we are going to do here is we are going to consider the positive side, or let me say the positive sign. You see, we have two signs here. We have the negative and positive, right? We are going to consider the positive sign so that when this is less than this, still we are going to get positive, because when you consider the negative, and if let's say this one is less than this, then we are going to get what? Negative, right? So we don't want to get something like that. So we are going to consider the positive side. So we are going to have y to the power m to be equal to x plus root of x squared minus 1, right? So now what we can do is we want to make sure we don't have this 1 to the power 1 over m, right? So what can we do? For us to take care of this, then we need to multiply this one by m and multiply everything here too by m. So we are going to have y all times m, then x plus root of x squared minus 1 all to the power m. So that this guy will cancel this guy, and we are going to have y is equal to x plus root of x squared minus 1 to the power m. Right. So we were able to simplify the equation in a such a way that we can now differentiate. So now the next thing for us to do is to do what? Differentiation. So let me copy this one to the next page, and then we start doing the differentiation, right? So this one is so long. So we are going to have something like this. Now y1, because we are dealing with um, Leibniz, right? So when I'm differentiating this function is like a chain rule, or let me say composite function, right? So here I can start differentiating the function by using the power rule. So I will not touch the one in the what? In the bracket. So that's the power rule. So the power rule says that drop the m, then subtract 1. So that's what we've done. Now that we are done with the power rule, we didn't touch the one in the bracket. Now the next thing is for us to differentiate the one in the bracket here. So we are going to have something like times. When I differentiate x, I'm going to have 1 plus. Now this function right here can be written as so root of x squared minus 1 is the same as x squared minus 1 to the power 1 over 2, right? So we can use the power rule to also differentiate. 1 over 2 will drop, then we subtract 1. So we are going to have 1 over 2 x squared minus 1 minus 1 over 2. So I subtracted 1 here, I dropped the half here. Now you see that I didn't touch the one in the bracket. So when I'm done, I need to differentiate the one in the bracket here. When I differentiate x squared, I'm going to have 2x. And when I differentiate negative 1, I'll get 0. So this is what I'm going to have after the first derivative. So now let's see what you are going to get. M x plus root of x squared minus 1 to the power m minus 1. Now this m minus 1 here, if I have something like a to the power m minus 1, this one can be written as am times a to the power minus 1, which is the same as am divided by a, right? So we can change what is here and write it of this form, right? So here we assume that this is our a, right? So this one we are going to have something like of this form. So I'm not going to bring the minus 1, then I'll divide this one by x plus x squared minus 1. So the minus 1 that I took from there is the one that I brought it down here. Then times 1 plus. Now this 2 here will cancel this 2, right? And then we know that if I have something like a to the power minus 2, this is the same as 1 divided by a squared, right? So I'm going to have something like 1 divided by x squared minus 1 to the power 1 over 2 times x from that side too. So now let's try and simplify it, then we take another derivative. Now, why are we going to take another derivative? Let's see. We are taking another derivative because of, I didn't even explain. Let's look at the function. You see, when we had y, let me explain something. When we had y, this one we could have used the Leibniz formula to start doing the differentiation, but we didn't do that because of what we are going to show. We want to show that this is equal to 0, and if we use the y that we've gotten, it means that we're going to get only this term, right? And when we differentiate it just one, like what we've done, we are going to get this term. So it means that for us to get this term again, for us to get this term also, we need to differentiate second time. So this is the first differentiation, which is here, right? Because when I differentiate the function 1 and I want to go to the nth derivative, then it will be n plus 1, right? And this one here, when I differentiate the function 2 times and I want to get to the nth derivative, then I'm having this. So that's the reason why we need to differentiate. When we are done with the first derivative, we need to take another derivative again, right? So what are we going to get? M x plus root of s squared minus 1 to the power m divided by x plus root of x squared minus 1, right? Times, now we can find the LCM here. If I have half here, is the same as root. So when I'm finding the LCM, I'm going to have root of x plus, let me say, is it x? No, it's supposed to be x squared rather. Yeah, good. So this one is going to be s squared minus 1. So the half is the one that I've turned into root. Then the top will be root of x squared plus 1, sorry, minus 1 plus x. I hope you understand what I'm doing here. So this one is up here, right? So this can be taken as root, right? So if I want to find the LCM, this is over 1. So the LCM here is this one. So this is over 1. 1 goes here, the same thing here. Then this times this will give us this. Then this one goes here, 1. 1 times x will give us this. So that's what we are going to get. You get it? Now, what you need to know is addition is commutative, right? So if I have a plus b is the same as b plus a, right? The idea of this plus x, you can see that it's the same thing here, but it's just we interchanging it. X plus this and then this plus x. So that is the case. We are going to have this one to cancel this, right? So we are going to have something like, now we are going to have something like y1 is equal to m x plus root of s squared minus 1 to the power m. Then this one will be divided by root of s squared minus 1. Wow, nice. But let's look at something here. We can see that the one up here is the y, right? Is equal to y here. We want to simplify it so that when we are taking the next derivative, we are not going to struggle. So this one here is equal to y, which we can see it right here. So in place of this, I'll make it y. So I'm going to have y1 is equal to my divided by root of x squared minus 1. So you see, because of I did that simplification there, the equation has become so simple. Like so simple. It's so simple for us to differentiate. Now what I can do is, this is divided by 1. So I can multiply this one by this. I can multiply this one by this. So I'm going to have y1 times root of x squared minus 1 is equal to my. As I told you, anytime I want to differentiate something and I see root, I want to make my life so simple. So I want to make sure that I take care of the root. So what I'm going to do is I'll square this and then I'll square this one too, right? So when I do that, I'm going to have y1 times root of x squared minus 1 all squared, which is equal to my all squared, right? So let me pick this one and let's send it to the next page, right? So I'm going to have something like this. I'm going to have something like this. Now when I square this, since it is product, I'm going to have y1 squared times Now the one with the root will be x squared minus 1, because this will cancel this, and then this one will square this. And then this one is going to give us m squared y squared. So now we can differentiate. I think we've done something similar in the video that we had this form. Yes, we've done it before. I think so, right? And I was even telling you we can use the Leibniz theorem to also do the next thing, right? So now what we can do here is now we are come to differentiate again. Yes, we are come to differentiate again because we need the second derivative. So this is a product rule. This is a constant, so this is not a product rule. So here, first I'll maintain y1 squared, then I'll differentiate the one in the bracket, which will be 2x, plus, then I'll maintain x squared minus 1, and then I'll differentiate this, right? So let me move this one, like y1 squared is like y prime squared. So if I want to differentiate this, I'm going to have 2y1, then I'll subtract 1, which will be 1, times, then I differentiate the y prime, which will be y prime prime, right? So when I move it to the Leibniz term, I'm going to have 2y1, right? This is to the power 1, so let me remove it. Then times this one will be y11, or let me say y2. That's the Leibniz theorem. So this is going to be times 2y1 y2, right? So we are done with the product rule from there. Then what will be the derivative for the right hand side? M is constant, so I differentiate y squared, and I'm going to have 2y times y1, right? So I use the power rule. 2 drops down, I subtract 1, then when I finish, I need to differentiate the y, then I have y1. So let's try and simplify. I can see y1 here, y1 here, y1 here. I can just cancel that. I can see 2 here, I can see 2 here, I can see 2 here. I can also cancel it out. So the idea is I'm going to divide through by 2y1. So I'm going to have y1 times x plus x squared minus 1, y2 is equal to m squared y. So when I divide through by 2y1, this one will be left with m squared y. Then when I divide through by 2y1, this one will be left with this and y2. Then when I divide through by 2 and y1, one of the y1 will be left and will be left with x also here. So this is the second derivative, because now we have the y1, we have the y2, and we have the y0. Because so let me show you something from the previous. So the y0, when we find the nth term, this is, we are going to have this. And the y1, when we find the nth derivative, we are going to have something like this. And then the y2, when we find the nth derivative, we are going to have something like this. So we have a long way to go. Let's go and continue. So now let me arrange this: x squared minus 1 y2 plus x y1 minus m squared y is equal to 0. So we are done with the derivative, but we can see that our solution, what we are showing, is in the form of what? The nth derivative, right? So what we need to do is we need to find the nth derivative. So we are going to pick them term by term, right? Then we solve. So this is one trick that you need to also know. You need to also learn under Leibniz theorem. Now we have this plus this plus this. So I need to pick this one, and then I apply the Leibniz theorem. Plus I need to pick this one, apply the Leibniz theorem. I pick this, I apply the Leibniz theorem. So I'll start from here. I'm not picking the minus, so I'll start from here. Now if I pick m squared y, then here my u will be equal to m squared, because I'm picking the one that I can differentiate to a constant term, and the next one I can differentiate to 0. And since m is already a constant term, it means that when I differentiate this one, I'll get 0, right? Then now I'll pick vn to be equal to what? Y. So now here I cannot find y1 because m is constant, so sorry, u1. So u1 will be equal to 0. So I don't need to do any differentiation, but I need the nth derivative for this one. So what will be Vn1, I mean Vn prime, is the same as y1. What will be Vn2 is the same as y2. So it implies that Vn will be also the same as what? Yn, right? So we can apply the Leibniz theorem for this. So what will be the Leibniz theorem for this? M squared y will be equal to, remember, we are using n combination 0, then u0, right? We said u0 is the same as u. So this one will be m squared, right, times, let me write the formula here for you. So we had it, this to be equal to n combination 0, u0 vn n plus n combination 1, u1 vn n minus 1 plus up to n combination n, un vn 0, right? So that's what we are doing here. So when you pick the first term, u naught is the same as u, right? And then we need the vn n. So the vn n is yn, right? But we cannot go any further because we don't have u1. Because u1, when I just do u1, I'm going to get 0. So I'll just end here. We know that n combination 0 is 1. So this is going to give us m squared yn. And we can see that we have something like m squared yn here, right? So we are almost there. We are getting there small. Right. So this is the n derivative for this one. So let me call this one equation 1. We will come and add them, right? So the next is I'm going to pick this one and also solve it, right? So that's what I'm going to do. Let me pick this one and put it aside here. Right. So I'm going to pick this one, right? So I'll clean up the whole of this one and work with that one too. So now I'm picking x, y1. My u should be equal to x because the one that I can differentiate to what? Constant term. So u1 will be 1, u2 will be 0, so we don't need it. Then vn will be equal to y1. So what will be vn1? Since this one is y1, it will be what? Y2. And then this one can be written as y1 plus 1. What will be vn2? Vn2 will be y3. And then this one can be written as y2 plus 1. What will be vn3? Vn3 will be y4. And this one will be written as, this one can be written as y3 plus 1. Why am I doing this? You remember the other video I was trying to demonstrate what I'm doing here. Now I'm doing this one so that I can find the vn, right? Because if I use this one, I cannot see the pattern. But here I can see some pattern here. If I have u1, 1 is here plus 1. If I have u2, I can see 2 here plus 1. If I see 3 here, I can see 3 here plus 1. So if I see n here, then this one can be written as yn plus 1. So that was the reason why I was doing it in such a way that I can see it, right? I can see the pattern. So 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, and n plus 1. So that will be the nth derivative, right? That will be the nth derivative. So now let's go and find y1. This is going to be n combination 0, u naught is x, and then vn n is yn plus 1 plus n combination 1. What is u1? u1 is 1, so times 1. Then what is vn n minus 1? Vn n minus 1. So since we have vn n, we can find vn n minus 1. So vn n minus 1 will be, this one will be n minus 1. So this one is like, now our n here is the same as n minus 1. So we are going to replace the n here by n minus 1, which will give us yn minus 1 plus 1. So this is going to give us yn, sorry. So we are going to multiply this one by yn. Then when we simplify this, we know that this is equal to 1. So we are going to have x y n plus 1 plus, we know that this is equal to n, so this is going to be n y n. So if you don't know how to do this combination, I think I gave this one in some videos. N combination r is equal to n factorial divided by r factorial, or if it is k, you can use k2 as well, then n minus r factorial. So that's what we can use to check what we are doing. So I'll call this one to let me write, I will call this one to equation 2, then I'll clean the rest of the solution. Then now let's look at the last one here, x squared minus 1 y2. So here my u will be equal to x squared minus this. What will be u1? u1 is equal to 2x, and then what will be u2? u2 will be equal to 2. Right. Now what is my vin? Vin is equal to y2. So who can guess the nth derivative? Right. So when you do it, you practice. This one is good for you to see that yn should be equal to vin n should be equal to n plus 2, right? Because this one is like you have vin 0 and this one is 2. So if you want to get to n, then you need to, so this one is like 0 plus 2, right? But I can go through the process very quick for you. So vin 1 will be equal to y3, which is the same as y1 plus 2. Then vin 2 will be equal to y4, which is equal to y2 plus 2. So vin n will be equal to yn plus 2. So I have 1 here plus 2, 2 here plus 2. So n here plus 2. So that's what you are going to get for the vin n, right? So now what can we do? Let me clean up some of the solution. Let me pick this guy right here, and then let's try and simplify this one too as well. So I need this guy right here, and then the rest of the solution I don't need it. So what will be x squared minus 1 y2? This is equal to n combination 0. Our u naught is the same as u, which is x squared minus 1. And then our fin n is this. So we are going to have yn plus 2 plus n combination 1. u1 is 2x. What will be vin n minus 1? Vin n minus 1 will be equal to, so as I said, this replaces by n. So this one is going to give us yn minus 1 plus 2, which is equal to yn plus 1. So this one will be yn plus 1. Then n combination 2. What is u2? u2 is 2. So we are going to have 2 times. Then we will need vin n minus 2, right? So vin n minus 2, we are going to have something like this. Vin n minus 2, we need to plug this one here. So we are going to have yn minus 2 plus 2, and this is the same as yn. So this one will be times yn. Good. So now the next thing that we need to do is for us to simplify. So this is the same as n combination 0 is 1. So we are going to have x squared minus 1 yn plus 2, then plus. Now what are we going to get for this? This one is n. So we are going to have plus n times 2x yn plus 1. Then what are we going to get for this? N combination 2 is the same as n minus 1 divided by 2 times 2yn. So if you want to verify, you can use this one to verify, right? You will see that we are going to get this. We did some previous video, so you can refer to that, right? So let me clean my equation 1 here and continue. So now I will have x squared minus 1 yn plus 2 plus 2xn yn plus 1. Then here this one will cancel this. So I'm going to have plus n minus 1 yn. So now we have gotten the nth derivative for this, this, and that. So now we can combine them, right? So it will be this plus this minus this. So what is the nth derivative for this? So it will be this plus this plus that. Don't forget, you can see that this one is the one here, this one too is the one here, and this one is the one here. So we are going to add this to this to that. Then we see if we are going to get the results that we've gotten in the previous video. So let me add them. Let me clean up the solution up here and add them, and let's see. So we are going to have x squared minus 1 yn plus 2 plus 2xn yn plus 1 plus n minus 1 yn. So this is the one that I wrote, which is for this. Then this one is here. So I'll write that one, which will be plus xyn plus 1 plus nyn. Then the last term, which is this one, is equal to this. So I'll have minus m squared yn, right? And is equal to 0. So the whole term here, we saw that it is equal to 0. So now let's group like terms and go and check the final results and see if they are the same, right? So do we have some common terms here? Yeah. So we have yn plus 1, yn plus 1. We have yn. So we can group like terms. So this one will be x squared minus 1, yn plus 2. Then we have yn plus 1, yn plus 1. So that one will give us plus x plus 2xn yn. Then plus we have yn. So we are going to have in brackets, I can expand this one, and then I'll have n squared minus n, right? And then plus n minus m squared yn. So if we are confused, this is the minus m squared with this, and then when I come with this one, this is the n right here with that, which is also here. Then I expanded this, which will be m squared minus n. Is that right? Good. So now we are going to have x squared minus 1. Let me clean up the solution here. I think we are done with this one. So yn plus 2 plus x plus 2xn yn plus now this will cancel this. So we are going to have n squared minus m squared yn is equal to 0. So let's go and check and see if we are getting the right result. So I'll copy this. No, let me go and copy what we wanted to show and bring it there. So let me copy this one. We want to see if we have gotten the right answer. So let's go. Okay. So let me paste it here and see if we have gotten the right answer. So let's compare. We have this one here. We have this one here. It's just the same. Okay, we have this and this one here. So here, okay, I think they factored the x out here. So let's do so. So this will be x squared minus 1 yn plus 2 plus here when I factor x out. Now when I factor x out, I'll bring this one first. So this one, when I factor x out, I'll have 2n, then plus 1, then yn plus 1. So this one should be yn plus 1 too as well, because that's what we did from here. yn plus 1 as well. So plus n squared minus m squared yn is equal to 0. Whew. So this is how, the some of the Leibniz function also works. So sometimes, because sometimes they won't give you the whole process for you to go through. Sometimes the question will be, you will start from here, right? They will give you this and they will ask you to find the nth derivative. So as we did, we pick this one, we find the nth derivative. You pick this one, you find the nth derivative. You pick this one, you find the nth derivative. When we finish, then you sum them up, right? By choosing your u and your m. Don't forget, whenever we choose u based on the one that we can differentiate what a constant term, right? I hope you enjoyed it. Give me thumbs up in the comment section and see you in the next video.